Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan. Ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity in how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Okay, andito na naman po kami sa ating radio station. Okay, so good afternoon everyone. Happy New Year also. So to our listeners and viewers, most especially to our grade 9 learners. So this is our first RBI and live discussion for this year ng science of course. Okay, kaya alam ko medyo may mga excited ulit na makinig.
Excited talaga.
Yes, excited talaga ulit na makinig at manood ng ating napaka-exciting na topic ngayong hapon na ito. Okay, di ba Ma'am Donna?
Okay. We would like to greet our Chief Education Supervisor, Officer in Charge, Sir Rodrigo V. Pascua, our Assistant Principal, Ma'am Ruby Guillermo, all the head teachers and teachers of this institution, and most especially to our learners, lalo na sa mga grade 9. Sana samahan nyo kami hanggang matapos ang ating inihandang live discussion para sa hapong ito.
Okay, so bago tayo magtuloy-tuloy, atin munang pakinggan ang ating RBI.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong, sulong edukalidad, Dance Radio. Learning is amazing.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science. This is your class, and this is Science.
Good day, everyone. I am your radio teacher in science, Teacher Benjelo P. Santiago. I want you to have your own learning activity sheets in science for this week, your notebook, and a pen. I hope this radio broadcast instruction can help you understand better our lesson for this week. Are you ready for today's lesson?
Yes, ma'am.
Let's have a short review on our lesson in chemistry last school year. Can you still remember?
Yes, ma'am. One lesson we had was the different atomic theories proposed by different scientists.
That's true. Can you remember one atomic model that describes the atom?
Yes, ma'am. The atomic model that describes the atom is Rutherford's atomic model, ma'am. According to this model, an atom is mostly an empty space and its mass is concentrated in a small region at the center called nucleus.
Exactly. According to Rutherford's model, where are the protons and neutrons located?
In the Rutherford's model, the protons and neutrons are inside the nucleus, while the electrons are distributed around the nucleus, ma'am.
That's right. Another is the planetary model proposed by Niels Bohr. How does the planetary model describe an atom?
The planetary model describes the electrons of an atom to move in orbits around the nucleus similar to the way planets like the Earth moves around the sun, ma'am.
Very good. It seems that you are now ready for the next lesson. After this lesson, you are expected to Number 1. Describe the energies and positions of the electrons using the quantum mechanical model of the atom. And number 2. Determine the distribution of electrons in the orbital. Have you experienced watching fireworks display last New Year's Eve, class?
Yes, ma'am. It's fascinating to watch.
Yes, it is fascinating to watch because of the different shapes and colors they emit when ignited to spark. What are the common colors of fireworks you usually observe?
The common colors of fireworks are yellow, blue, green, orange, and red, ma'am.
Very good. Do you know what is responsible for their beautiful colors?
Maybe because of the materials firecrackers are made of, ma'am.
Very good idea. It is due to the arrangement of electrons within the atoms of the elements present in the firecracker.
Wow! I am excited to discover more about the atom, ma'am.
Firework effects are produced by the combustion of explosive materials present in fireworks. These explosive materials are also called metal salts. Metal salts emit characteristic colors of light when heated. Each firework is packed with just the certain amount of chemicals, particularly metal salts, to create these beautiful and colorful lights. During its ignition, each chemical element releases different amount of energy, and this energy determines the color or wavelength of the light being emitted.
So each color of light has specific wavelength, ma'am?
Yes, among the visible light, the red color has the lowest energy and has the longest wavelength. Violet light has the shortest wavelength and has the highest energy. I'll explain further when I come back after a few reminders.
Trivia time! How much do you know about atoms? Test your knowledge with these fascinating facts. Electrons are negatively charged particles that orbit around the outside of the nucleus. They spin so fast that it can be difficult for scientists to observe them. They are attracted to the positive charge of the protons and are the smallest particles in an atom. You can fit 2,000 of them into a proton. This fascinating facts is brought to you by LittleHouseOfScience.com, Kagham, Doña Aurora National High School, and this station.
It's Science Time!
You are listening to Teacher Benjulu.
I'm back! When compounds of different elements are ignited, the hot gaseous atom begins to emit light of definite color. This is observed through an analysis of light given off by the vapors of element. What is the instrument used?
The instrument used is a spectroscope, ma'am. With the use of a spectroscope, one can detect a series of narrow lines or inline spectrum on the light given off by an element.
Exactly! These spectral lines suggest different energy levels in an atom. Each line in the atomic spectra of elements suggests definite energy transformation within the atom. Bohr stated that electrons are moving around the nucleus in circular path or orbit at definite distances from the nucleus. What happens to the energy of the electrons as they move farther?
The energy of electrons increases as they move farther from the nucleus, ma'am.
Very good! The energy increases as the distance of the orbit from the nucleus increases. These orbits are also known as shells or energy levels, and are assigned each a number. N equals 1, N equals 2, N equals 3, or letters such as K, L, M, N, O. What happens if the electron received an extra energy?
The electron jumps into a higher energy level called the excited state, ma'am. The electron in the excited state can return to its original lower energy level or ground state by releasing of energy in the form of light.
Great idea! That is, if an atom has only one electron like hydrogen. How about other atoms? According to the quantum mechanical model of the atom proposed by Schrödinger, the atom is composed of heavy nucleus surrounded by clouds of negative charges. What are these negative charges again?
The negative charges are the electrons, ma'am.
Very good! The electrons or the negative charges are not in circular orbits around the nucleus. They do not move in a fixed position nor stay away from the nucleus.
With the movement of the electrons, it is not easy to tell their exact location in the atom, ma'am.
Very good! This model suggests that it is impossible to know the exact position of the electron. This is known as the uncertainty principle. Look at the image on page 1 of your learning activity sheets. Can you see the image of the atom?
Yes, ma'am. The atomic nucleus is seen and located at the center, ma'am.
What about the electrons? Can you see the electrons in the model?
No, ma'am. We cannot see the electrons.
Very good observations. Based on the quantum mechanical model, it would be impossible to plot a definite path or orbit for the moving electrons. We can only guess the most probable location of the electron in a given instance to be within a certain region of space surrounding the nucleus. The location of the electrons in the quantum mechanical model of the atom is often referred to as an electron cloud. The model states that the electrons can probably be found in a space around the nucleus called the atomic orbital or simply the orbital. What is again the role of atomic orbital, class?
The atomic orbital describes the probable location of electrons, ma'am. An atomic orbital is the region around the nucleus where the electron is most likely to be found. It serves as the house of the electron. It can accommodate a maximum of 2 electrons, and the charge of the electron cloud is negative.
Very good! Remember that the quantum mechanical model is based on the probability rather than certainty. Based from the image of the model on page 1, where would there be a higher probability of finding an electron?
In the darker areas surrounding the nucleus, ma'am.
Very good! The darker the area, the greater is the possibility of finding an electron. The quantum mechanical model describes the probable location of electrons in atoms by describing the principal energy levels, the energy sublevels, the orbital, and spin. Electrons occupy definite principal energy levels. What is used to represent each energy level?
Each principal energy level is represented by a principal quantum number n, where n is equal to 1, 2, 3, 4, and 5, ma'am.
Very good! 1, 2, 3, 4, and 5 are the energy levels. As the principal quantum number n increases, the orbital becomes larger. The electron spends more time farther away from the nucleus, and the atom's energy level increases. The quantum model also reveals that each principal energy level consists of one or more energy sublevels. What are these sublevels?
The different sublevels are S, P, D, and F, ma'am.
Exactly! The number of energy sublevels for each principal energy level are not the same. Electrons occupy first the lowest position. Electrons usually occupy the lowest sublevel, which is S. What is the second sublevel?
The second sublevel is P, ma'am.
Very good! What about the third and fourth?
The third is sublevel D and the fourth is sublevel F, ma'am.
Exactly! Sublevels define the orbital shape. The letters S, P, D, and F stand for sharp, principal, diffuse, and fundamental respectively. Please refer to page 3 of your activity sheets. How many sublevels are there in the second energy level?
There are 2 sublevels, ma'am. Sublevel S and P.
Very good! Again, what about in the third and fourth energy levels?
There are 3 sublevels in the third energy level. They are S, P, and D sublevels. While 4 in the fourth energy level, S, P, D, and F sublevels, ma'am.
Exactly! And there is 1 sublevel in the first energy level and 2 in the second energy level. In determining the maximum number of electrons in the different energy levels, what is the maximum number of electrons in the first energy level?
There are 2 electrons in the first main energy level, ma'am.
Yes, you were correct. There are only 2 maximum electrons in the first energy level since there is only 1 sublevel. What is the sublevel in the first energy level, class?
The S sublevel, ma'am.
Very good! Locating the probability of finding electrons does not end in the energy sublevels because we still have the orbitals. Atomic orbitals are the places surrounding the nucleus of an atom where electrons are most likely to be located at a given time. We can compare orbitals to rooms where electrons are located.
Is the number of orbitals the same in the different sublevels, ma'am?
No. Each sublevel has different number of orbitals. Each orbital can only hold a maximum of 2 electrons. On Table 1 of your learning activity sheets, the first column gives the number of orbitals in each energy sublevels. On the second column is the maximum number of electrons. How many orbitals are there in the s sublevel?
There is only one orbital in the s sublevel, ma'am. This means that the maximum number of electrons in the s sublevel in the first energy level is 2, ma'am.
Very good. How many orbitals are there in the p sublevel?
There are 3 orbitals. So the maximum number of electrons in the p sublevel is 6, ma'am.
Very good answer. How about the number of orbitals in the d and f sublevels?
There are 5 orbitals in the d sublevel and 7 in the f sublevel, ma'am.
Exactly. The maximum number of electrons in the f sublevel is 14 because of its 7 orbitals.
Aha!
We will discuss how to determine the maximum number of electrons in each energy level after a few reminders.
Oy, Pedro! Nagpabakuna ka na ba?
Oo naman, Petra. Bakunado na yata to. Dapat ang bawat isa ay mahikayat ng magpabakuna. Bata, matanda, tara na!
Tama ka dyan, Pedro. Kung may bakuna, siguradong protektado tayo laban sa virus. Kaya magpapabaksin na rin ako.
Tandaan, magpabakuna, siguradong protektado ka.
Isang paalala mula sa Tonyong Aurora National High School at ng himpilang ito.
It's Science Time!
You are listening to Teacher Benjulu.
And I'm back! The maximum number of electrons in the main energy level is determined by the formula 2n raised to 2, where n is an integer that designates each energy level. For the first main energy level, K, n is equal to 1. In the second main energy level, L, n is equal to 2. In the third energy level, n is equal to 3 and so on.
Ma'am, what does 1s raised to 2 mean?
The symbol 1s raised to 2 indicates that there are 2 electrons in the s orbital found in the first energy level. If we have 2p raised to 3, this means there are 3 electrons in the p orbital in the second energy level. The electronic configuration of an element describes how electrons are arranged in successive sublevels and orbitals.
Is it applied to all atoms, ma'am?
Yes, this arrangement normally applies to atoms that are in the ground state. The following rules are to be followed in deriving the electronic configuration of an element. Number 1. The Aufbau principle. Each electron occupies the lowest energy orbital available. What does this mean?
It means that an electron in the ground state normally occupies orbitals in the lowest available energy level, ma'am.
Excellent answer. Each added electrons occupy the orbitals according to increasing energy, with the lowest orbital filled first. When writing down an atom's electron configuration, or in the distribution of electrons of an atom, we begin at the lowest energy level and add electrons to higher energy sublevels until the required number of electrons are present. How should the electron distribution start?
The 1s comes first because its n value is low. Hence, lower in energy, ma'am.
That's right. There will be overlapping of energy, and it begins as n increases in value. For instance, 4s comes first before 3d. As n increases, the energy of the electron increases. How about rule number 2? Will you state it?
Rule number 2 is the Polyexclusion Principle, ma'am. It states that a maximum of 2 electrons may occupy a single atomic orbital only if they have opposite spins. For example, beryllium with an atomic number and number of electrons equal to 4. The orbital in the first energy level and in the S sublevel is filled with 2 electrons. And so with the orbital in the first energy level and in the S sublevel is filled with 2 electrons. And so with the orbital in the second energy level, sublevel 2.
Very good! Will you write the electron configuration of beryllium?
1s raised to 2 and 2s raised to 2, ma'am.
Very good! Let's have the third rule. Hans' rule states that a single electron with the same spin must occupy each orbital in a sublevel before they pair up with an electron with an opposite spin. What does Hans' rule imply?
It implies that 2 or more orbitals of equal energy are available wherein electrons will occupy them singly before filling them in pairs, ma'am.
That's right! You are now ready to answer Activity 1 titled, Come Distribute Me. Directions. Write the orbital notation and electron configuration of the elements on the table. Write your answer on a separate sheet of paper. Number 1. Sodium has atomic number and number of electrons equal to 11. What is the electron configuration?
The electron configuration is 1s raised to 2, 2s raised to 2, 2p raised to 6, and 3s raised to 1, ma'am.
That's right! Number 2. Magnesium has an atomic number and number of electrons equal to 12. What is the electron configuration?
The electron configuration is 1s raised to 2, 2s raised to 2, 2p raised to 6, 3s raised to 2, ma'am.
Correct! Number 3. Aluminum has an atomic number and number of electrons equal to 13. The electron configuration is what?
The electron configuration is 1s raised to 2, 2s raised to 2, 2p raised to 6, 3s raised to 2, and 4s raised to 1, ma'am.
Great job! All your answers are correct. Please answer the remaining activities on your learning activity sheets after this episode or in your most convenient time. This time, let's sum up our lesson. How does the quantum mechanical model describe the energies and positions of the electrons?
According to quantum theory, it's impossible to know the exact position and momentum of an electron at the same time. The principal quantum number n describes the average distance of the orbital from the nucleus and the energy of the electron in an atom.
The larger the value of n, the higher the energy and the larger the orbital. The electron configuration of an element describes how electrons are distributed in its atomic orbitals. Electron configurations of an atom follow a standard notation.
Very good! Before we end, let me ask you 2 important questions. First, what is the information provided by the 4 quantum numbers about the distribution of electrons in the atom?
The 4 quantum numbers are used to describe completely the movement of each electron within an atom.
Precisely! Second, what model describes electron positions in probable locations around the nucleus? Why?
It is the quantum mechanical model, ma'am, because each orbital around the nucleus resembles a fuzzy cloud around the nucleus. The atom is composed of heavy nucleus surrounded by clouds of negative charges. This model suggests that it is impossible to know the exact position and momentum of an electron at the same time. This is known as the uncertainty principle.
Very good! You really understood the lesson. At this moment, can you give your most significant learnings for today's discussion?
Ma'am, it is the quantum mechanical model which states that electrons can probably be found in space around the nucleus called the atomic orbital.
Very good! What more?
The principal energy levels and indicate the relative size and energy of an atomic orbitals. Electrons occupy definite principal energy levels which are represented by the principal quantum number n, ma'am.
Correct! What else?
The electronic configuration of an element describes how electrons are arranged in successive sublevels and orbitals. This arrangement normally applies to atoms that are in the ground state, ma'am.
Right! You have very good reflections, my dear learners. I would like to congratulate you because you really did well today. I hope you have learned a lot from our discussions. Before we end, I would like to acknowledge the teachers behind this School on the Air lesson. Ma'am Donabel G. Velasco, our scriptwriter. Ma'am Rosabel R. Brillo, our language editor. Ma'am Annabel A. Rodriguez, our content editor. Ma'am Riza N. Marzan, our technical specialist. And I am Teacher Benji Lupi Santiago, your radio teacher in science. Thank you very much. Goodbye. Stay tuned for our live discussion.
Dance Radio, siniparalan sa radyo, atid namin magkabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Okay, so katatapos lang ng ating RBI airing. So, dumako naman tayo sa ating live discussion para mas lalo nating maintindihan kung ano nga ba yung quantum mechanical model of the atom. So, ngayong hapon, makakasama natin ang ating mga naggagalingan, mga teachers ng science. Siyempre, hindi lang science, lahat naman tayo magagaling, di ba? Okay, so kasama natin ngayon si Sir Ronnie Abalos, okay, si Ma'am Annabel Toribio, si Sir Prince na kasalukuyang naka-zoom ngayon, si Ma'am Donabel Velasco na siyang scriptwriter, at ang inyong lingkod, si Ma'am Fernandina Benito. So, Ma'am Donna, ano nga ba yung magiging focus ng ating discussion ngayong hapon?
Okay. So, again, good morning to all our viewers of today. Good afternoon. To all our viewers of today's live discussion, I hope you will learn more about the lesson for this week in Science 9, which is all about the quantum mechanical model of the atom. And for our objective, After this RBI, you are expected to, number 1, describe the energies and positions of the electrons using the quantum mechanical model of the atom. And number 2, determine the distribution of electrons in the different orbitals. Okay, Ma'am Dimes.
Okay, thank you, Ma'am Donna. So, quantum mechanical model. So, ito yung kailangan talaga na kailangan nating makinig. Kailangan din pinakinggan natin ng mabuti yung ating RBI. Kasi andun yung mga iba't ibang mga models ng atom bago siya yung ginagamit natin ngayon na model. Tama ba ako dun, Ma'am Donna? Okay. So, i-review nga muna natin. Actually, yung first na nag-propose ng model is, actually, it's not Bohr's. Hindi si Niels Bohr di ba, Ma'am Donna?
Okay,
It was, maraming mga kasi yung kay Niels Bohr Oo. So, nauna muna dyan si Rutherford. Okay. Si Rutherford, pero maraming mga naging problema dun sa Rutherford's model. Okay, so from the Rutherford's model, yun naman nag-propose din si Niels Bohr. Si Niels Bohr. Pero si Niels Bohr ata, Ma'am Donna, is a student of Rutherford before. So parang naging tandem sila doon Okay, so the Bohr's model has an atom consisting of a small positively charged nucleus orbited by negatively charged electrons. Yun yung kay So, he proposed the Bohr model of the atom in 1915. So, because the Bohr model is a modification of the earlier Rutherford model, some people call the Bohr's model the Rutherford-Bohr model. Okay. So, yung sa kanya kasi, yung kay Niels Bohr, it is the exact, is the exact path of the electron. It was restricted to a very well-defined circular orbits around the nucleus. Hindi gumagalaw? Okay. Okay, so ulitin ko Okay, so di ba si Niels Bohr, siya yung nag-propose ng the Bohr model of the atom in 1915. Okay, kaya lang yung Bohr's model, I should say, is a modification of the earlier Rutherford's model. So ngayon tinatawag yung Bohr's model, tinawag din siya na the Rutherford's model, the Rutherford-Bohr model. Okay, so the Bohr's model is a planetary model in which the negatively charged electrons orbit a small positively charged nucleus similar to the planets orbiting the sun, except that the orbits are not planet, of course, or are not planar. Okay, so the gravitational force of the solar system is mathematically akin to the Coulomb force between the positively charged nucleus and the negatively charged electrons. Yung nandyan sa natin, sa slide natin, inaano ko lang siya, elaborate ko lang siya. Okay, nakikita nyo ba yan? May mga yung positively charged nucleus. Nakikita nyo siya, di ba? Meron tayong mga different shells. Okay, so, basahin ko lang din ito. The Bohr's model of an atom, electrons are moving around the nucleus. Ano yung sabi ko kanina? Parang kagaya siya ng planets na nag-o-orbit around the sun. So, electrons are moving around the nucleus in circular path or orbit at definite distances from the nucleus. So, this is similar to yung sinabi ko kanina, yung planets natin revolving around the sun. So, electrons in its orbit have a definite energy. Okay, next slide, sir. Okay, so after nung kay Niels Bohr, nag-ano din naman sumunod si Schrödinger. Sino ba si Schrödinger? Ano naman yung sinabi ni Schrödinger? Okay. So, sabi ni Schrödinger, actually his name is Erwin Schrödinger. He is an Australian physicist took the Bohr atom model one step further. Anong ibig sabihin nun? Kumbaga, kasi ang nangyayari, parang from one model to another, kumbaga, parang ano lang siya parang, anong tawag dito, Ma'am Donna? Parang inaayos or parang nag-a-update. Hindi nawawala yung original, ina-update lang siya, parang ganun. May mga naidadagdag, na kung may makita silang hindi maganda or hindi appropriate doon sa ano na yon, nire-revise nila, inaayos nila. So, yun yung kay Schrödinger. Schrödinger used mathematical equations to describe the likelihood of finding an electron in a certain position, or he used the wave particle duality of the electron to develop and solve a complex mathematical equation that accurately describe the behavior of the electron in a hydrogen atom. Yun yung the quantum mechanical model. Okay, so the quantum mechanical model of the atoms comes from the solution of Schrödinger's equation. Quantization of electron energies is a requirement in order to solve the equation. Hindi yung kagaya nung kay Bohr's model, which is quantization was simply assumed but with no mathematical basis. Okay, so eto naman yung tingnan nyo yung pagkakaiba kanina nung model ni Bohr sa model ni Schrödinger. Okay, so ano yung ginawa ni Schrödinger? Gumamit siya ng mathematical equations to describe finding an electron in a certain position. Okay, yun yung tinatawag natin na quantum mechanical model. Okay, ano ba yung ginawa din ni Niels Bohr? Hindi siya gumamit ng mathematical equation to predict yung exact path of an electron, but it predicts the odds of the location of the electron. Okay? Tama ba yun, Ma'am Donna? May idadagdag ka ba, Ma'am Donna?
Okay, so let's have the next slide. Okay, the location of the electrons in the quantum mechanical model of the atom is often referred to as the electron cloud. Okay, you can see that on the screen. Yung makikita mo yan, yung mga shaded parts, may mga darker spots siya, may mga lighter spots. The electron cloud can be thought of in the following way. So, imagine placing a square piece of paper on the floor with a dot on the circle representing the nucleus. Now, take a marker and drop it on the paper repeatedly. So, ulit-ulitin natin yan. I-drop natin yung marker. Making small marks at each point the marker hits. If you drop the marker many times, siguro 100 times, the overall pattern of dots will be roughly circular, like that on the screen. If you aim progressively fewer dots as you move away from the center, each dot represents a location where the electron could be at any given moment. Because of the uncertainty principle, there is no way to know exactly where the electron is. An electron cloud has variable densities. A high density where the electron is most likely to be, and low density where the electron is least likely to be found. So, basing from the figure we have on the screen, yung mga dark shaded areas where there are more dots, no, that we can observe, these are the high density parts of the atom where these electrons are most likely to be found. Okay, so any more, Ma'am Dina? We can have the next slide, please.
Okay, so saan na ba tayo? So,
ayan. So we have here the location of the electrons. Ito siya in the quantum mechanical model of the atom. This is often referred to as the electron cloud. Yan, parang blurry
siya.
part siya, no? And the darker region near the nucleus indicates the higher probability of finding the electron because it is more dark than the outside part of the atom, while the lighter regions farther from the nucleus indicates a lower probability of finding the electron. Okay? So, can we now have the next slide?
So, ito na yung sa...
Ayan. So, the quantum mechanical model describes the probable location of electrons in atoms by describing the principal energy level, the energy sublevel, and the different orbital, including the spin of the electron. So, yan yung mga i-discuss natin mamaya as we go on with our live discussion. Okay? Okay, Ma'am Dines. What are these energy levels?
Okay, yes, Ma'am Donna. So, energy levels, they are also called the electron shells. Okay, they are fixed distances from the nucleus of an atom where electrons may be found. Okay, so energy levels are like the steps of a staircase, di ba? Yung hagdanan natin. You can stand on one step or another, but not in between the steps. So electrons can occupy one energy level or another, but not the space between energy levels. So maliwanag yan. You can occupy one energy, or the electrons can occupy one energy level. Di ba yung sa hagdanan? Okay. Or another, but not the space in between the energy levels. Or so, yung stairs natin, one after the other yon. Okay. First step, second step, but not doon sa gitna. Between those energy 1 and energy 2 for energy level 2, for example. Okay. So, yes, Ma'am Donna.
So, okay na?
Kikita mo, yes.
Okay. These electrons in the energy level 1, okay, makikita natin yan, ano. So, can you see? We have the nucleus at the center, yung merong kang positive sign doon. And the first orbit there. Kaya tinawag siyang planetary model ni Niels Bohr. It's because of the presence of the different orbits where the electrons, according to Niels Bohr, are found. And we have how many energy levels? We have 4. So they are named as energy level 1, 2, 3, and 4. Or we can assign or designate letters for these energy levels or shells na tinatawag natin. They can be K, L, M, N. Pare-pareho lang yon, okay? And you can see their numbers. Now, what are these numbers? Usually, these are the maximum number of electrons that can be found in each energy level or principal energy level. As you go farther from the nucleus, habang lumalayo ka sa nucleus, electrons at higher energy levels have more energy. So, habang lumalayo yan, at kailan siya lumalayo? Lumalayo siya every time these electrons will be able to absorb energy. This energy can be in the form of any form of energy. Pwedeng heat, pwedeng, and then pwede rin mawala yan. Okay, they could release the energy. And electrons at higher energy levels have more energy, and their energy increases by a fixed discrete amount. Okay.
So, Ma'am Donna, parang yung sa fireworks. Ito, Ma'am Donna, yung sa
yes.
fireworks. Oo.
Okay, we have here, yan. Parang sa fireworks. Later, natin mamaya
Yes.
yun.
Oo.
Okay, next we have the summary. This is now the table wherein we could see the sub-levels, of the first 4 energy levels. Ma'am Dines, yung 4 na energy levels natin kanina doon sa orbit. 'Di ba meron tayong 4 na orbit doon
Yes,
sa dun sa isang model kanina.
Yes, ma'am.
Yun, those are the principal energy level where electrons are most probably be found. But these sublevels, these energy levels are also composed of different sublevels. And these sublevels are designated by letters. Meron tayong tinatawag na sublevel S. Meron tayong tinatawag, S is the only sublevel found in the first energy level. And then in the second energy level, we have the S and P sublevel. Doon sa third, we have the S, P, and D. And in the fourth, we have the S, P, D, and F. Okay. Yes. Ma'am Dines, how many, okay. We have also the orbitals.
Yes, the
Meron
orbitals.
sinasabing orbitals
Yes, ma'am.
dyan.
Pero
So, what
ma'am,
are these orbitals?
Di ba ma'am Donna, may ibig sabihin yung mga sublevels na yun, yung S,
Oh, yes.
P, D, at saka yung F?
Yes.
Oo, parang yung S yata is sphere. Tama ba ako, ma'am?
Yes.
Okay.
And then
Yung P, ano naman yung P, Ma'am Annabelle, yung P? Is it principal?
Yes.
Okay. Yung S, ma'am, is sharp. Sharp. Sharp.
Merong iba. Meron ding iba na sphere, peer.
P is for principal.
Oh, yes. Oo,
D
yung
is
saan
for
natin.
diffuse. And F is for
fundamental.
Yes,
fundamental.
fundamental. Meron kasi yung sa ibang books, merong iba sphere, peer, meron pang nilagay dito dumbbell.
That's the shape.
Yun yung shape.
The
Yes,
shape.
according to their shape.
According to their shape.
Yes, yung named by their
Shape.
shapes yon.
Yung shape ng orbital.
Oo, yung sphere, peer, dumbbell, at saka yung... Pero yung F fundamental pa din
Clover.
kasi siya eh.
Clover yung isa.
Yung sa... Oo,
Clover.
oo.
Yung
Yes.
apat. Okay.
Okay.
And then, Ma'am Dines, we also have the number of orbitals. What
Yes,
are these
ma'am.
orbitals?
Okay, so yung mga orbitals na yan, meron din tayong, on the first, di ba yung kanina sabi ni Ma'am Donna, there are 4 principal energy levels, and then these 4 energy or principal energy levels, meron din tayong tinatawag na the different sublevels. So, dun sa first energy level, meron tayong isang sublevel. Ilan naman yung number of orbitals dun sa sublevel na yon, di ba? Isa lang din. Tama
These
ba ako, Ma'am
orbitals,
Donna?
tandaan natin, these orbitals are like rooms, para
Yes.
silang apartment.
Mm-mm.
Kunwari sana yung, if we can compare the sublevels to a floor. One, kunwari meron kang building. Ang sublevel mo is the different floors
yes.
of a building. And then you have the orbitals, these are the number of rooms or apartment where an occupant is most probably be staying.
1, 2,
And
3,
these
4.
occupants
Yes.
are the electrons. So, pwede natin silang i-compare doon para mas maliwanag yung ating description with
yes,
this
ma'am.
different
Orbitals.
space in the atom where these electrons are most likely to be found. Okay. So, in the S sublevel, there is only one orbital. So,
Yes.
isang room lang yan. There is only one room. And in every P orbital, there are how many, in every P sublevel, there are 3 orbitals. So,
orbitals.
meaning, there are more rooms for electrons in the P sublevel.
Yes.
Okay?
And then,
So, in the D sublevel, there are 5 rooms. So, there are 5 orbitals. And in the F, ilan sa F? Sir Ronnie, ilan sa F? Hindi ko makita.
F, 7.
There are
Okay. So, there are 7. Paano nakuha yung mga yung mga numbers dyan sa total possible occupying electrons doon sa last column natin? Ma'am Annabelle, saan nakuha yung mga 2, yung mga 6,
Okay, we must remember that every orbital can contain 2 electrons, ma'am. That's why for the S sublevel, the number of orbitals has 1, and therefore the number of electrons there is a total of 2. For the S sublevel, we have one orbital. I'm sorry, we have 1 orbital, and then the other one for the P sublevel we have 3. So we have for S sublevel 1 we have 2 electrons, and then for the 3 the number of orbitals in sublevel, we have P for 3, and then multiply 3 by 2, making it 6, ma'am. And then we have a total of 2 plus 6 is 8. Same is true with the next ones.
Okay, kung gusto nyo lang i-apply yun sa mathematics nila, ma'am, pwede naman kung yung sa number of orbitals, n, di ba yung n principal energy level natin is n. So, n is squared. Tama, ma'am?
Yes.
Oh, n is squared. So, 1 squared is 1. So, kaya 1 yung una. Then, 2 squared is 4. So, 4 yung orbital sublevel natin. Then, 3 squared, 9. So, 9 yun, number of orbitals in the sublevel. And next is 16. Doon naman sa total possible occupying electrons, that is 2n squared.
Yes. 2n squared.
2n squared. Yun yung in-explain ni Ma'am Annabelle.
Okay. So, yan. Okay, we can see here the spin, no? Yung spin ng electrons, no, in the different orbitals found in the different sublevels of the different energy levels, no, in the different atoms. Okay. So, makikita natin dyan. Ano yung mga arrows dyan? Are these arrows representing something? Ano yung nire-represent ang mga arrows dyan sa different boxes natin, Ma'am Dina?
The maximum number of electrons, ma'am.
Okay. So, may ano siya,
In
no?
its
May
sublevel,
directions
oo. May
sila.
direction na pataas, bababa. Kasi
Okay.
hindi siya pwede, yung pag-spin niya, ma'am, di ba? Hindi siya pwedeng magkasunod, parang
Okay.
ganun. Kailangan
So,
opposite
it
yun.
means to say that these electrons are continuously moving, no? Yan yung sinisignify ng mga arrows found in the different orbitals. Okay, can we have the
Next slide.
next slide, please? Ayan.
Ayan siya.
Ano ito? Ma'am Dina, ang ganda, no? Okay. So, we can see here the different colors of arrows. No? These are your, ano yan? Ano yung mga arrows na yan na pababa? Nakikita nyo? Okay. So, these are
Energy.
okay, ito yung mga energy ng mga electrons when they jump to different energy levels. So, makikita natin yan yung, ano yung unang line dyan, that is in level 2. Diba? Yung pinakababang, mababang line, horizontal line, that is level 2. And then, meron kang level 3, level 4, 5, and 6. So, what can you see? Meron kang energy absorbed. Yung first arrow that is going up, an arrow going up, so that means to say, when the electrons absorb energy, they go up to a higher energy level. So, yan yung nakikita natin dyan sa yellow arrow. Can you see that?
Yes.
Maliwanag ba? So, umakyat siya, and then, it will not stay there for long because the energy of these electrons can also be, what? Pwede siyang ma-release ulit. Okay? And what happens when the energy is released? Anong nangyayari, Ma'am Dines, kapag ang energy ng mga electrons that they absorb is released? Siyempre, aakyat muna yan kapag nag-absorb ng energy, ano? So, the distance from the nucleus increases, no? And as long as the electron stays in its given orbit, so kapag nandun lang siya sa orbit niya, walang absorption ng energy. So, ibig sabihin, hindi siya excited. Okay, nasa ground state siya. Okay? But the time when the time comes that these electrons jump to a higher energy level, yan na yung nag-absorb sila ng energy. Okay, do you have any idea what will happen if the electron receive an extra energy? Of course, they jump to a higher energy level. The electron can jump into a higher energy level. This is also called the excited state, no? The electron in the excited state can return to its original lower energy level. So, makikita natin dyan yung mga 4 na arrows. Can you see the 4 arrows? Yung pinakamababa, saan siya umabot? Sa level 3, ano?
Level
Okay.
3.
So, dun sa level 3, what is the color? Kasi when these electrons releases the energy, ano yun? May spark of light silang ini-emit. These are photons of units of light, no? And they emit different colors, and these colors depend on the wavelength of the energy. May mga wavelengths kasi yan. That's why they release the color. Ito yung dahilan kung bakit we have different colors kapag New Year. Ano yung inaano natin? Yung mga fireworks, di ba? Yan yung reason kung bakit yung mga fireworks natin, they emit different colors. Okay? Kasi after the ignition of the different metals found in the firecrackers, no, pagka wala na yung init niya, nag-emit yan ng energy and they also emit light. Okay. And then the green one, kapag nasa level 4, ibig sabihin mas mataas ang energy ng electron kapag ka yung kulay ng color niya is green. Tama ba, Sir Ronnie? Ano yung pinakamataas na kulay dyan? Ano yung pinakamataas na energy?
Sa level 6,
Okay,
violet.
the violet. Ano? So, this is now the reason why firecrackers emit different colors. Okay, in the diagram, we have simplified picture of some of the different energy level transitions possible for the hydrogen atom. Yan yung sa hydrogen. Okay? So, the higher the frequency, photons are associated with larger energy transition. Kapag mas mataas ang frequency, mas mataas ang energy. So, nagbabago ang color niya depending sa amount ng frequency. And also, sumasama dun yung kanyang wavelength. Okay? So, ayan. Nakita mo naman guys.
Sa fireworks.
Saya na yung fireworks natin. They release the energy as light. Now, different atoms have different arrangements of electrons. They give off light of different colors. Yes. Ano yan? Mamdines. Saan natin nakikita yun? Ano
Sa fireworks.
Ayan, hindi yan.
Yung susunod?
Yes.
Sa fireworks. Okay. Okay, so eto. Okay, so yung sa notation natin.
Yes.
So the principal...
Saan natin nakikita yan, Ma'am Dines? Yung 4P5. Usually, saan natin nakikita yan?
Yung sa 4.
Saan natin nakikita yan? 4P5. Notation yan.
Yes, it is a notation sa pag nag-ano tayo ng electron configuration.
Okay.
Sa electronic configuration.
Nakikita natin yan
Sa pag-distribute
Okay, sa distribution
ng electrons in the different energy levels.
Okay. It means that 5L, okay, yung notation na 4P5, okay, yung 4 there is the principal energy level, sub-level P, and how many electrons are found in the P sub-level? You have 5 electrons in the P sub-level. Okay, so, Ma'am Dines, are we now ready to have the next topic? Yung next topic natin is, I think is very exciting.
Yes. Ito
Yung gustong-gusto yan. Pagka sa unang tingin, ang hirap, pero pag nasundan,
very exciting siya, ma'am.
Okay,
Yung pag-distribute ng electrons in the different energy levels.
Okay, let's now call on
Ma'am Annabelle Toribio to explain to us electron configuration.
Thank you, Ma'am Donna and Ma'am Dines. So before I start with this electron configuration together with Sir Ronnie and Sir Prince, may I just want to greet my 9 Mendel, 9 Darwin, and 9 Pasteur. Hello, good afternoon, and to all grade 9 learners. So we have here the definition of electron configuration. Sir Ronnie, pakibasa na nga lang.
Okay. The electron configuration of an atom is the representation of the arrangement of electrons distributed among the orbitals, shells, and subshells Commonly, the electron configuration is used to describe the orbitals of an atom in its ground state, but it can also be used to represent an atom that has ionized into cation or an ion by compensating with the loss of or gain of electrons in their subsequent orbitals.
Okay, to make it shorter, electron configuration is actually a representation of the arrangement of electrons. Okay, so the electrons are distributed among the orbital shells and sub-levels. Okay, so to discuss about the electron configuration, we need to know about general rules to consider to figure out the electron configuration of a certain atom. We have 3 principles, including Aufbau principle, Hans rule, and Polyexclusion principle. Let's begin with the first rule, which is known as the Aufbau principle. So, Sir Ronnie, saan kayo nanggaling itong salitang, medyo hindi tayo familiar sa salitang Aufbau, di ba? So, saan kaya nanggaling ito?
Okay, so yung Aufbau, the word ay nanggaling in a German term which means building up.
Okay, that's right, sir. That is why this principle, Aufbau principle, may also be called building up principle because of that. So, this states that electrons occupy orbitals in order of increasing energy level, meaning we start from the lowest energy to the highest energy level. So, electrons cannot occupy higher energy levels if the lower energy levels were not occupied yet. The order in which the orbitals are filled with electrons is shown or given here in our screen, which starts from 1s, 2s, 2p, 3s, 3p, and so on. Actually, there is another representation of this order of orbitals in periodic tables, which is known as the mnemonic device. Okay, it's the mnemonic device. So if you have with you your periodic table, you can see there the arrangement of the electrons in a mnemonic device, which can be seen in the next slides. Do we have that there, Sir Mark? The periodic table. And wala pa.
Okay,
can we go back muna?
Wala yung mnemonic device, ma'am. Only
So
the periodic table.
Yeah, but most periodic tables, yung mga commercial ones, have this mnemonic device actually. Okay, we go back to the first rule, which is the Aufbau.
Okay, Ma'am Annabelle, baka meron magtanong. According to the Aufbau rule kasi, the order of the orbitals ay may be filled higher if the first lowest energy level, then pataas. Baka magtanong sila, bakit yung 4S mas naunang nalalagyan bago ang 3D? Mas mababa yung 3D in terms of numbers, di ba? Mas mababa naman ang 3 kaysa sa 4. Bakit mas mauna ang 4?
4S, before
yes,
3D.
Yes.
That can be shown in the Aufbau, right?
Yes, ma'am.
Okay, so the reason behind this is that though mathematically shown already, the 3D orbital has been mathematically shown to be lower in energy compared to 4S, okay, orbital. The reason why we fill in first the 4S orbital before the 3D is that the electrons in the 3D orbital are closer to the nucleus of the atom, making these electrons in the 3D orbital to repel stronger. That is why, or making them a slightly higher in energy level than the 4S. Okay? That's why, instead of 3D ang pipilapan natin mauna, we start with the 4S. Okay? Okay, let's have one example here. Sir Mark? After the, this one. The electron configuration of chromium, for example, is, we have here the orbital diagram for I know this is not orbital diagram. Yung shorthand method ba in representing the electron configuration of chromium, which is argon, the electron configuration of argon, and then we have here 3D5 and 4S1. If we follow the Aufbau principle, we have here on the other side argon, and then 3D4, 4S2. However, sabi rito, ARD, 3D5 for S1 and not 3D4 for S2. O, una nating finilapan ng 4S2 kaysa sa 3D. Kaya meron tayong 4S2, 3D4. Kaya lang, meron tayong exception na dun sa rule natin. Sabi rito, this exception is attributed to several factors such as the increased stability provided by half-filled subshells and the relatively low energy gap between 3D and 4S sublevels. So, mas slightly higher lang ang sublevel ng 3D kaysa sa 4S. O, yung energy dyan. So, ang nangyayari, para mas maging stable itong chromium natin, the outermost shell, which now is the 3D, right? 3D na ang last, okay? Para maging stable yan, half-filled half-filled subshells are more stable and fully filled subshells are more stable. So yung 4S natin dyan, to make that chromium more stable, the one electron in the 4S orbital will jump into the 3D orbital, making the 3D now 3D5 and 4S1. So medyo nakakalito kasi nga, kulang, hindi na puno yung 4S, hindi rin na puno yung 3D. Both of them are half-filled.
Yes.
Diba ang D has a maximum of, or can contain a maximum of 10 electrons, and S can contain a maximum of 2 electrons. So both of these orbitals now are half-filled, making chromium stable. So yan ang dahilan kung bakit, nakakalito, bakit yung ibang electron configuration ay ganito. Okay, so that's the first. Let's have the second one. The second principle is known as the Polyexclusion Principle. It says here that no two electrons in an atom can have the same 4 quantum numbers. Okay? Mga anak, you can look into the slide here, and you can see here our example for the ground state electron configuration of helium, which is 1s2. So according to the Polyexclusion Principle, no two electrons in an atom can have the same 4 quantum numbers. So Sir Ronnie, let's try to identify yung mga quantum numbers natin dito. Yung principal, ano yung principal quantum number natin dyan?
Okay, the principal, that's 1.
1. Yung angular moment quantum number natin, 0. Then the magnetic is also 0. And then the electron spin, they are already different.
Okay, the positive 1/2 and the negative
1/2. So yun, it conforms with the Polyexclusion Principle. All of the 3 quantum numbers above, the principal quantum number, the angular momentum quantum number, and the magnetic quantum number are the same, but one of the quantum numbers, which is the electron spin, is different.
Yes.
Okay, that's the Polyexclusion Principle. Let's have the third one and the last for this. We have the Hans rule. So according to this, Ronnie?
Okay. According to the Hans rule, the most stable arrangement of electrons is the one in which the number of electrons with the same spin is maximized.
Okay. So let's take an example here, carbon atom. The ground state of the ground state electron configuration of carbon is 1s2, 2s2, 2p2. And we can see here the orbital diagram for carbon. The outermost energy level here is 2p.
2p2. Okay.
2p is an orbital having how many? P is a sublevel having how many orbitals?
So there are 3 orbitals, ma'am.
So we distribute these 2 electrons in the P. In the P, sir. Pabalik muna, sir. Okay. We distribute the two electrons in the first 2 P orbitals first.
Yes.
Before, wala naman na tayo ipapares. So meaning, all the spins are the same.
Okay.
Muna.
So violation yun kapag nilagay mo, yung meron ng up arrow, down arrow ulit sa isang orbital. Tama, ma'am? Dapat yan,
we distribute all the electrons in the same spin first before pairing up from the first orbital.
Kung 2p4 dapat yan, so tatlo yung may laman, yun isa lang ang may partner.
Fully filled siya. Yes. So those are the 3 rules to consider when we talk about the electron configuration of atoms. We have the Hans rule, Polyexclusion Principle, and Aufbau Principle.
Okay.
So we will have more examples.
Examples and demonstration of Sir Prince.
Okay, nawawala na daw ang connection ni Sir Prince.
Sige.
Okay, Sir
Ba-
Ronnie.
bago yan. So, bago tayo mag-jump dyan sa kay Sir Prince, tignan natin muna yung application na yun sa periodic table. So, next slide, please. So, next slide. Okay, let's start. The periodic table is a tool of organizing the known chemical elements. The elements are listed. Okay. Let's start with H, hydrogen, and helium. The electron configuration are 1s1 and 1s2 respectively. With helium, the N or the principal energy level is 1, shell is filled. These two elements make the first row of the periodic table. So mapapansin natin yan, yung dalawa, yung nasa taas isang element yan, yan yung first N natin, o period 1 natin. So kung magtataka kayo, bakit kaya hindi lang sila magtabi? Yung helium kasi hindi po pwede kasi yung 1A and 2A, ang general characteristics ng mga yan, nag-give sila ng electrons. Samantalang itong helium, yung isang element sa period 1, ay stable siya, so hindi siya nag-give ng electrons. Tama, Ma'am Donna. Next. So the next two electrons are the lithium, beryllium, would go on the 2s sublevels. The two elements are adjacent to the periodic table. So, mapapansin nyo yan, may dalawang 2s, dalawang element yun, then 2p. 2p siya. Next, mamaya makikita sa picture. Yan, yung 2p. Next slide. So, the same din yan, 3s, then 3p. Then, this is the D block. Yung nasa gitna ng periodic table. So, ibig sabihin, yung energy in electron configuration nila, mostly nasa D yung last niya. Mostly, or depende sa pagkakasulat ng electron configuration pa rin nila. This is the 3 sub-level. 3D. Kasi yun sa S block and P block, kapag in element ay nasa D, P block, ang last sub-level niya ay always P. Kapag sa S naman, ang last ay S. Okay, next.
Energy level.
Okay, ito na yung sasabi natin. Yung 1A, the S block, yun yung 1A and 2A, yung nasa left ninyo, yung color, blue. Yung nasa right nyo naman ay yung P block. So, bibilangin nyo yan, meron siyang 6 elements lang yun. Kaya maximum niya ay 6 electrons lang. The middle, or the green, yan tatawag nating D block. And the yellow color, o yung nasa baba, makikita nyo sa periodic table, tinatawag nating transuranium element ay ang F block. Okay, next. Okay, ito na. The first two columns, in-explain ko kanina, the first two columns of the left side of the periodic table are where the S subshells are being occupied. Because of this, the first two rows of the periodic table are labeled as S block. Similarly, the P block, the rightmost 6 columns of the periodic table, the D block is the middle 10 columns, at yung nasa baba naman, the F block is the 14-column section that is normally depicted as detached to the main body of the periodic table. Okay, Ma'am Donna, meron okay.
Meron susunod yan, sir.
So, tingnan natin yan. Yung neon, 1s2, 2s2, 2p6. So, mapapansin natin, ang pinaka-last niya na sub-level ay P. Kung babalikan natin doon sa periodic table, ang neon ay makikita natin sa P black. Even the aluminum. Tama, ma'am? Aluminum, argon, or let's see the calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Kung titignan natin anong period nyo makikita ang calcium. So, yung pinakamataas ang energy level niya. So, 4. So, nasa period 4 ang calcium. Nasa ang black ang calcium. Nasa S black. Ganun siya kung paano tumingin using the electron configuration. Yun na nakasulat yan, argon, yan yung shorthand notation ng electron configuration. Yes, ng aluminum at ng calcium. Ma'am Donna?
Okay, Sir Prince. Wala na si Sir Prince. Okay. Balikan natin yung slide. Ano yan? Slide na yan. 22? Slide 22. Habang wala si Sir Prince. 22, 21.
20. Ito yung 20.
Ayan. So, okay. So, habang wala si Sir Prince, tingnan natin yung electron distribution, ito, ng hydrogen. Nakikita niyo, Sir Ronnie? Hindi maliwanag sa akin. Okay. So, with one electron of hydrogen, so hanggang anong energy level lang siya? Yung electron niya kapag na-distribute natin hanggang sa
First energy level.
first energy level, sub-level,
S.
Orbital,
1.
isa lang.
First one lang kasi 1 lang na may electrons.
Yes. So,
Electron.
makikita natin dyan, isang electron lang ang nandoon sa isang orbital because it is only one electron ang i-distribute natin dyan. And for the second atom there, the second atom, ano yung second atom dyan?
Helium.
Helium. Ayan. So, ano yung saang energy level lang siya?
First din, ma'am.
Okay. So, makikita natin dyan. Paano natin nalalaman na hanggang sa first energy level lang?
Because one orbital, ma'am, can contain 2 electrons, so it does not reach the second energy level anymore. It must fully occupy the first and the only orbital in the S sublevel.
Yes. Baka naguguluhan sila. Kasi nakikita natin dyan, meron kang 1s doon sa lithium na dalawang puno ng electron, di ba? Yung doon sa pangatlo, we have lithium. Tapos meron kang 2s. Meron kang 2s with 1 electron. So, bakit siya 2s kaagad? Because you are now, the electron now is distributed to the second energy level. So, balikan natin yung, yung slide kanina na meron yung first slide yata kanina, Sir Mark. Sir Mark, yung first slide natin, yung may bilog, yung may mga orbits. Yun. So, yan. Makita natin dito sa orbits dito ng atom natin in the first energy level na meron siyang dalawang electron. Ngayon, if an atom has 3 electrons to be distributed, the third electron to be distributed now will already be distributed in the first S sublevel or in the S sublevel of the second energy level. Okay, let's go back to slide 22.
Okay, dyan na si Sir Prince.
Okay, Sir Prince. Hello, Sir Prince.
Mike.
Okay, Sir Prince is here.
Sir Prince.
Sir Prince, patay ang mic.
Magde-demo si Sir Prince.
Sorry na.
Okay,
Na-disconnect
He
ako
will be
kanina.
demonstrating
Dahil sa internet natin. Okay, so i-apply na natin yung rules.
distribution of electrons.
I-apply na natin yung rules na present ni Ma'am
Okay na,
Annabel
Sir Prince.
kanina.
You may now start.
Hello, naririnig ba?
Yes, Sir
Naririnig
Prince,
ba ako,
clear.
Ma'am?
Oo.
Yes, Sir Prince.
Okay na.
Okay. So review lang natin na yung tatlong rules na i-apply natin para sa paggawa natin ng electron configuration. One is the off-bow principle, second is the Hans rule, and third is the Polyexclusion Principle. Okay, for the off-bow principle, wag na tayo mag-alala kasi meron naman tayong mnemonics. Kagaya nito, itong screen na nandito sa left, nakikita nyo ba yung mnemonics natin?
Yes, Sir Prince.
Ma'am Annabel?
Yes, sir.
Very
Okay, so
colorful.
nakikita ba yung mnemonics natin? Okay, so sundan lang natin yung arrows from 1S kasi according to the off-bow principle, we will fill up the lowest energy level muna, which is 1S. Papataas, sundan lang natin yung arrow hanggang 8S kung madami yung electron hanggang ma-reach na yung 8S. Okay, so gawin natin yung electron configuration ng element with an element symbol of N, which is nitrogen, and the atomic number of nitrogen is 7. So if it is a neutral atom, the number of electron is also 7. So let us apply yung ating 3 rules. First is the Aufbau principle. Saan natin lalagay yung unang electron? It should be at the lowest energy level, which is 1s. And second rule, the Polyexclusion Principle, dapat in an orbital, merong dalawang electron at opposite ang spin nila. So the second electron should be in the opposite spin. Okay, so meron na tayong dalawang electron out of 7, nabawasan ng dalawa. So ilang pa natitira? 5. Meron pa tayong 5 electron na dito. Okay, next energy level is the 2s. Okay, applying the Polyexclusion Principle, dapat dalawang electron dyan. So, na-distribute na natin ulit yung dalawa, meron pang natitirang
3.
Tatlo. Okay, ito na ngayon ang medyo tricky. So, in filling up the p orbital or p subshell, meron kasi siyang tatlong orbital eh. Anong rule ang i-apply natin dito? It's the Hans rule. And according to the Hans rule, dapat let's fill up the orbitals in one direction muna bago mag-pair or mag-double magdoble yung mga electrons natin. Okay, so we have here the first electron, the second electron, and the third electron. Pero na-distribute na natin yung tatlo, so wala na tayong natitirang electron. Kaya ito na ngayon ang ating orbital notation ng electronic configuration ng element na nitrogen. So if we are to write the shorthand notation na ngayon ng kanyang electron configuration, it's 1 S. Kung ilan yung electron sa orbital na yan, that's 2. Next is 2 S2. And for the next level, it's 2p. Ilan yung electron na nasa p subshell? 3. So ang electron configuration ng nitrogen is 1s2, 2s2, and 2p3. Okay, let us try another example. This time, let us do sodium and A. The atomic number of sodium is 11. So if it's a neutral atom, the number of electron is also 11. Distribute ngayon natin itong 11 na electrons na to, applying the 3 rules, the Aufbau, the Hans rule, and the Polyexclusion Principle. So according to the Aufbau, start with the lowest
Energy
start with the level with the lowest energy, pero kailangan dalawang electron according to the Pauli's exclusion principle. Dalawang electrons sa bawat orbital na opposite ang spin. Okay, so from 11 na distribute na natin yung dalawa, so meron pang 9. Okay, next, fill up na natin yung 2s orbital. So nabawasan ulit ng dalawa, so may 7 pa. Ngayon, paano natin i-fill up itong 2p subshell? Kasi meron siyang tatlong orbital, Hans rule ang i-apply natin. So kailangan tagi-isang electron muna in one direction. So na-distribute natin yung tatlo, meron pang natitirang 4 bago natin bigyan ng pair in the opposite direction. Okay, so meron pang natirang isa at yung isang electron na yon ay sa next higher orbital na, which is 3s. So kung bibilangin natin ilan yung electrons na na-distribute natin, it's 2, 4, plus 6, 10, plus 1, 11. So what is the shorthand notation of the electron configuration na nito ng sodium? It's 1s2, 2s2, 2p6, 3s, and 3s1. Okay, let us do the last example. This time it's chlorine with an atomic number of 17. So if it's a neutral atom, the number of electron is also 17. 17. Unang rule na i-apply natin is the Aufbau principle. Fill up the lowest energy level muna. Okay, so naglagay tayo ng dalawa. So from 17, nabawasan ng dalawa, meron na lang 15. Okay, next, Maglagay ulit tayo dito ng dalawang electron. So, meron pang natirang 13. Dito naman sa 2p subshell, pataas muna bago maglagay ng pair. So, ilan ang nalagay natin sa p subshell? Merong 10. So, ilan pa ang naiwan? Meron pang hindi pala 6. So, ilan pang naiwan? 7 pa. So, next, fill up natin yung 3s. Okay, so meron pang naiwan na 5. Saan natin makikita tong 5 electron na to? So, sa 3p, kailangan pataas muna according to the Hans rule bago natin lagyan ng pair. So, 5 yun, 3 na yung nalagay natin. Kailangan pa natin i-distribute ng 2. Okay, so to complete yung 5 naiwan, yan, na hanggang dito na lang tayo sa gitnang orbital. And if we are to write the electron configuration of chlorine, it's 1s2, 2s2, 2p6, kasi 6 yung electron dito sa p subshell, 3s2,
3p5,
and 3p5. Bakit 5? Kasi 5 lang yung electron dun sa p subshell. So that's 3p5. Ito na ngayon ang electron configuration ng chlorine.
So, meron pa, Sir Prince?
Okay, any additional information, Ma'am Annabelle and Ma'am Lonabelle?
Wala na sa akin, sir.
Okay, wala na rin sa akin.
Okay, so,
Yes,
Ma'am Knights, meron kang idadagdag?
Meron pa sana, kaso lang magta-time na daw eh. Oo. Oo, magta-time na daw.
Okay, sana nakinig sila, no?
Yes, nakinig
Kasi
sila.
napakaliwanag yung pag-explain ni Sir Prince kung paano natin i-distribute yung mga electrons in the different energy levels, sublevels, and orbitals.
Yes, Ma'am Donna, napaka-importante yan. Kasi yung number of electrons na i-distribute mo, diba, parehas sila ng atomic number. Tama ba, Ma'am Donna? So, yung sa atomic number pa lang, and then, dun sa distribution, makikita mo na yung mga iba't ibang, kumbaga marami nang pwedeng magawa pag na-distribute mo yung sa yung electrons using the electronic configuration. Kasi, alam mo na kung saang black siya, metal ba siya, maraming mga properties ng elements ang pwede mong ma-identify.
Okay. So, kailangan lang, pag ito yung lesson natin or any other topic in our subject, kailangan nating maging attentive, kailangan nating maging matyaga, lalo na ngayon because of our present situation. Kailangan mga anak, maging matyaga sa pag-aaral. No, di po ba?
Yes. Magtulungan, Ma'am Donna.
Medyo mahirap pero kailangan nating gawin. Okay? So, pasasaan ba at may intindihan natin yung lesson na yan? No, sa simula lang mahirap pero with
pag nandun ka na,
sa pagpupursige ninyo with your hard work, okay, madaling maintindihan. Okay po? So, to sum up,
to sum up, kung ano yung napag-aralan natin ngayong araw na ito, ngayong hapon na ito. So, according to quantum theory, it's impossible to know the exact position and momentum of an electron at the same time. So, this is known as the uncertainty principle. So, the principal quantum number, or the N, describes the average distance of the orbital from the nucleus and the energy of the electron in an atom. So, the larger the value of N, the higher the energy, and the larger the orbital. So, the electron configuration of an element describes how electrons are distributed in its different sub-levels.
Okay. And according to our model of the atom, electrons are distributed among the energy levels and orbitals of the atom according to certain rules. And each electron has a unique energy determined by the position of its orbital. When an atom absorbs the right amount of energy, an electron moves from its original orbital to a higher energy orbital that has a vacancy. Okay. So, this ends our session for today. I hope you learned a lot from this live discussion. If you have any questions or queries, you may text or message your subject teachers in science. Nine. Okay? So, ilan ba tayong teachers nila pwedeng pagtanungan?
Si Ma'am, may dagdag si Ma'am Jennifer Lacambra. Yes,
Okay,
6.
so meron kayong 6 na teachers,
Yes,
sa
6 na
Science
teachers.
9,
7, 8.
na mag-a-assist sa inyo mga anak.
Pwede rin naman na magtanong sila sa mga grade 10 teachers, ma'am. Di ba?
Okay.
Kasi,
sino.
kahit sino sa mga science teachers natin.
Okay.
Okay, so, Ma'am Donna,
Maraming
enough for
salamat
today.
sa inyong pakikinig ngayong hapon. And I hope you will learn more as we have our next session for our week 2 next week. The same day,
The same time. Okay, so, goodbye. Ano pa? Mag-aral ng mabuti.
Okay, yan.
Kung sinend namin yung sa mga ibang klase, sa mga klase ko, sinend ko sa inyo yung PowerPoint na ginamit namin dito para kung meron kayong hindi maintindihan, you can go over with it, or pwede rin yung sabi ni Ma'am Donna kanina na magtanong.
Pwede rin silang makinig ulit
Oh, yes.
sa
Yung mga-
RBI natin.
Okay, so paalam.
Okay, bye.
Saan ba? 3 and 4. Hindi namin alam.
Hindi namin alam.
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and